Dear student, today after surface chemistry, we discuss the unit 6 general principle of extraction and isolation GPI for the metals, that is contains the less mass, almost about 3 marks. So each term in this chapter is very important and we should have the clear concept. Already I have discussed this chapter through Zoom, but some of the students demanded that give the video lecture. That's why I am preparing for you and you will see it. And what is the, to save the time, I have written the one part. So what is this chapter? First we know that mineral, already mineral क्या है, ore क्या है, and what are the types of the ore, and what is the occurrence of the metals, right? So mineral क्या है? You know it very well that a mineral are the chemically occurring substances and found on the earth crust from which the metal can be extracted, right? Now the term is ore. Mineral और ore में क्या difference है? First term is mineral, so I defined it, and another one is ore. What is the ore? All minerals, not all the ores, but the ores are the minerals. Why? Ore are the substances from which the metal can be extracted economically and profitably. That's why this is called the ore. That is the minerals from which the metal can be extracted economically, and metal can be extracted economically and profitably. This is known as the ore. Now the another one, the term is gangue, Gangue. What is gangue? Gangue क्या है? The unwanted impurities present in the mineral is called in the ore is called the gangue. Unwanted impurities. This is called this is gangue. This is unwanted. So during the extraction of the metal, it is very important to remove the gangue particle, although our metal cannot be pure. So this is the gangue. Now occurrence. So many metals occur in the form of their oxides, sulfides, carbonates, and the abundance of the metal, जैसे iron is the second most abundant metal, and aluminum the third most abundant metal, and then there are the important ores. Just I have given you in the that is note form. So you will the oxide important ore. जैसे if we take the aluminum, the important ore is bauxite, and cryolite Na3Al2 or Na3Al2F6, bauxite Al2O3 dot XS2. That if we take iron, that is oxide or hematite Fe2O3. Similarly, sulfide ore, carbonate ore, and this is sulfide ore of iron. Similarly, if we take copper, this is CuFeS2, copper pyrite, from which copper can be extracted. So this is all about that is important. So it is given in your book, and I have given also you the notes, so you will go through it. This is all the things are written, so this is no need. And we have to discuss these things: what is ore, what is mineral, what is gangue. Now And what we know about the metallurgy, the important term is metallurgy. मेटलर्जी क्या है, इसको हम लोग जानेंगे। मेटलर्जी, मेटलर्जी, मेटलर्जी क्या है? Different steps used for the extraction of metal from its ore, not mineral. Always we say the ore, because all ores can be called the mineral, but all minerals cannot be called the ore, because the ore from which the metal can be extracted, that cost should be very low, less, and it should be profitable. That's why. So the metallurgy, the different that is the steps used for the extraction of metal from their ore is called the metallurgy. So if you will see the flow sheet, just to save the time, I have written first here. This is the crude metal, that is called the ore, from which you crush and grind it. So it will convert it into the powder for crushing and grinding. And there are so many methods, so it is not possible to remove the by hand picking method. So we concentrate the ore. And the first is concentration of ore. Second step, concentration after crushing and grinding the ore. The concentration is done by 3 steps. First is gravity separation, another one is magnetic separation, and third one is flotation process, and fifth is fourth is leaching. And we know the principle only, not the process, because question is asked the examination, write the principle, and principle it depends upon only one line. So you will remember what is the principle. So gravity separation is called gravity separation. Separation. Question is asked in this year also, 1 marks question. Name the process of benefiction in which the metal is that is ore can be purified on the basis of the gravity or the density. You have to write the name of that process. So gravity separation, or this is also called hydraulic washing. So its principle, just I dictate you, just principle that will depends upon the density of the impurities and the ore. That will depends upon the density or the, that is the gravity of the impurity and the ore. This is the principle. This one lines you have written, I have already given you. So you will only understand it. Gravity separation. This is also called hydraulic washing. What is hydraulic washing? So your ore is converted into the powder form. This is what I am going to discuss. This is the process. So gravity separation table is there. Now powdered ore is kept there. Now the flow of water, current of water is blown through that ore. So the impurities which are lighter in weight, that will float over the surface of water and it will go through this water. And the ore that are settled on the gravity separation table. So this is the principle that will depends upon the difference in gravity or the density of the ore and the impurity. Is it clear? Now another one is magnetic separation. The principle magnetic separation, third process is called concentration. This is magnetic separation. Magnetic separation. Separation. Magnetic separation. Is it clear? Magnetic separation means the principle that will depends upon the attracting power of towards the magnet. If impurities are attracted, that ore can be purified. Is it clear? Now, if there is no such impurity, that so for that, in order to save time, if you will see the book, then I will show the diagram. This is the gravity separation process. What will happen in this process? There is a wheel, and this is the wheel and this will contain the magnet. Now there is a bed. Now there is a hooper. Is it clear? There is a hooper. Now we put the crushed ore on that hooper. And there are two collectors here and here. Now when we put the ore, powdered ore here, then it will move through the belt. If it contains the magnetic impurities, then it is attracted towards the wheel and it is collected here and the ore will separate. So what is the principle? That will depends upon the principle is the impurities is attracted by the magnet. This is the principle. And the third is froth flotation process. What is the froth flotation process? This is a very unique history. We will read in that part. What is the history? First you know the principle. History later on. What is the principle that this is principle based on the difference in the wettability of the ore by pine oil and the wettability of the impurity by the water. So the impurities get settled at the bottom of that tank and the ore will get stick with the froth that can be. So what is the in the froth that pine oil and xanthates that are used, they are called the collector, and there is another substances that is known as the froth stabilizers. So froth collector, the question asked, so you will see, then I will define next on the next part. To save the time, just I have taken it. So this is a tank, and here this is the water, and there is a pine oil, and this is a agitator. This is the wheel or churning for that process. Now the oil and the pine oil is taken. So when pine oil is taken, it is agitated. It will come into the form of the froth. Now this froth will contains at the pine oil. So this pine oil written here will act as a, this is called this is collectors, right? So this pine oil, so ore will stick with that froth and the impurities settle at the bottom, right? Now this is in this way the ore can be transferred in the another. So the principle, the ore is wetted by pine oil and the impurities by the water, and it will get settled. Now in this process, so this froth flotation process can only be applied for the ore that contains the sulfite. So we take as the collectors, thus that is the, I have told you, pine oil, fatty acid, xanthates, etc. These are called the collectors. Now that ask the term, what is the collector? That enhances the wettability of the ore, right? And the froth stabilizer. And in froth stabilizer, that is aniline is used as a froth stabilizer. Now the another term comes in this process, froth. The third process is froth. What is depression? D-E-P-R-E-S-S-A-N-T. Depression. That is, depression are the substances that helps to separate the two sulfide ore selectively by permitting the one ear to stick with the froth and preventing the others. So यदि दो सल्फाइड और है, जिंक सल्फाइड एंड द पीबीएस, और इन दोनों को सेलेक्टिवली सेपरेट करना है, तो हमको इसमें डिफरेंशिएंट लेंगे, और दिस डिफरेंशिएंट इज NaCN. So this NaCN will allow the lead sulfide to stick with the froth, and it prevent the zinc sulfide. It form a complex with NaCN. So zinc sulfide will not go the froth, and the two sulfide ores can be separated very easily. So what is the role of the diffraction? By adjusting the proportions of the pine oil, it will also actually. So question asked write the name of the different depression which is used to separate the zinc sulfide and the lead sulfide. We write its name, that is NaCl. This is NaCl. This one. This is NaCl. So this NaCl will act as a depressant. Now this is another process. What is leaching? Leaching we know is the process. This is also the process of conversion, concentration. What is the principle? You know the principle. Equation is given in the book. You can copy it. You can be understand by writing the equations. So what will happen in the leaching? Leaching is the process in which the ore is treated with suitable reagent or suitable chemicals in which the metals are soluble, impurities are not soluble. So metal is soluble, impurities are not soluble. So impurities can be removed by filtration. So leaching can be done by the following metals in order to purify the bauxite, ore of aluminium, by Bayer's process. There are three processes. Bauxite is treated with concentrated solution of sodium hydroxide, and then the solution is obtained, metal sodium aluminate. This is second step. It is treated with CO2, then it forms hydrated aluminum oxide, and sodium bicarbonate is formed. And the third equation to get the alumina, that is by heating the Al2O3 we get the alumina. So this whole process is called the leaching. The principle is very important, but is in this year it is asked name the process benefiction, in which a metal ore impurities not soluble in the suitable solvent but the metal. So you will write there the leaching. Leaching is the process. That's why leaching. And by that process, three metals can be extracted. Silver, there is a simple, this is called earther cyanide process. That is metal and Cn minus, this one plus H2O plus O2 form a cyanide complex. This cyanide complex will be treated with more active metal, that is zinc, and it converted the zinc complex and metal get removed. So this year the question asks, what is the role of zinc here in the process of leaching? This process of leaching, zinc will act as a reducing agent. All the things I have given, just you demanded that that can be explained by video lecture, so I am doing so. Now these three steps are obtained. Now concentration. Just after that, I have given you the alumina after leaving Al2O3, and from alumina the aluminium can be extracted by electrolytic process. Here by electrolytic process. So this is a steel tank. See here, and this is a tapping hole. Now this steel tank is carbon lined, and this carbon lined is that is acts as a cathode, and the copper strip, and it is contains the graphite rod, and they will act as the anode. Now here we will take at Al2O3 and we add Na3Al(F6), this one, and this is called chloride, and this is not the pure alumina obtained by the process of leaching. So what we are talking here, extraction of aluminium. All the things I have aluminium from alumina, Al2O3. Right? Now this process is called Hall-Herold process. So you will see the figure, it is given in your book. Just to save the time, we don't. This is the Hall-Herold process. You see, this is the figure. So this is a steel tank lined with carbon lining, acts as cathode. These are the so many graphite rod, and here we take as alumina and then cryolite, and the electric current is. This process is called Hall-Herold process. we must know the name of this process. What will happen on passing electricity? So the question is, what is the role of cryolite? Role of cryolite. This cryolite will have a role. It lowers down the melting point of alumina and increases the electrical conductivity. So this is the role of the cryolite. This is lower down MP of alumina, MP of alumina, and increases that is electrical conductivity. Electrical conductivity. This is electrical. So in this process, I know all the things, but the role of the sodium cryolite Na3LF6 is not known, then you are not able to answer such a question. So you go through the proper reading of the book, and that will help to answer the question, and that makes your knowledge very perfect for the cooperative examination. So this is a alumina and this is a chloride, and the role of function of cryolite I have written. Function of cryolite. Now what will happen? When we pass the electric current, on passing electric current, the following reaction will take place. Al2O3, that will give twice Al3 plus and 3O2 minus. Now this aluminum 3 plus 3, that is C. Where it will deposited? At cathode. And what will happen at anode? This C and this is O2. O plus this one, C plus O2, that is CO2. That is CO2. This O2 minus get converted into oxygen, and oxygen will, that is, react with the graphite, and it will convert it into CO2. So this graphite rod get exhausted. So it is replaced time to time and with the process. So this is the that is the extraction of aluminium from alumina by reaching you three element ammonium, Az and Au. For that the reaction is given in your book, you go through the book. Now the another one, when we concentrate the ore, what are the steps of the metallurgy? यदि आप कंसंट्रेट कर लेते हैं तो आप कंसंट्रेटेड ओर को हमारा काम होता है उसको मेटल ऑक्साइड में बदलें। तो ये मेटल ऑक्साइड में कैसे हम बदलेंगे, इस चीज को जानना जरूरी है। तो दिस इज कन्वर्शन ऑफ मेटल ऑक्साइड, कन्वर्शन ऑफ कंसंट्रेटेड ओर इनटू दैट इज मेटल ऑक्साइड। इसके लिए दो प्रोसेस होते हैं। पहला होता है कैल्सिनेशन। इस कैल्सिनेशन में क्या होता है, इट इज द पूछे गए हैं कैल्सिनेशन, इट इज द प्रोसेस ऑफ हीटिंग द ओर इन एब्सेंस और लिटिल अमाउंट ऑफ एयर। इन एब्सेंस, प्रोसेस ऑफ हीटिंग ओर इन एब्सेंस, एंड द प्रोसेस ऑफ हीटिंग or in absence of oxygen or air, a little amount or little amount we may say. What is the function to convert carbonate ore into their oxide? पहला। दूसरा, to remove volatile impurities As2O3. This is twice as 3O2, twice 4S, like that. यदि phosphorus है P4 plus O2, that is P4O10, like that. This is P4O10, 5O2, like that. And third one is to remove moisture in present. Remove moisture. All I have given all the things. Remove moisture. That's why I am not writing in your moisture. This one. So calcination क्या है? That is the process of heating the concentrated ore in absence of air or little amount of oxygen to convert, पूछा जाता है to convert carbonate ore into oxide, zinc carbonate may be converted, to remove volatile impurities if present and to remove moisture if present. This is known as the calcination. Again we come on the another aspects of this here. This is the roasting. What is the roasting? Roasting, R-O-A-S-T-I-N-G, roasting. So what is the process to heat the concentrated ore in presence of air to convert into oxide? Simple we write, right? Roasting क्या है? आपको पूछे what is the difference between the calcination and the roasting? First we know the roasting. Roasting वो process है जिसमें यानी concentrated ore जो सल्फाइड को ऑक्साइड में बदलता है. तो द ओर concentrated ore is heated in presence of air to convert into oxide. तो पर्पस क्या होता है? To convert sulfide into oxide. Sulfide into oxide. Second function होता है to convert, that is to remove volatile impurities, similar as, and to remove moisture. ये आपको तीन फंक्शन है. So what is the difference between the calcination and the roasting? Calcination in absence of air or little amount of air to convert carbonate into oxide. It is in presence of air to convert sulfide into oxide. Second, to remove volatile impurities, to remove moisture, to remove moisture. These two are same, but this one depends upon sulfide to oxide, and this is carbonate to oxide. So this conversion of state is complete. Now we come on step number, this is 3, that is 4. Conversion of metal oxide to metal. Conversion of metal oxide to metal. So that is explained in the extraction of copper and iron. So conversion, step 4, conversion of metal oxide to metal. This is by smelting. Smelting is कहा जाता है, that is zinc oxide है, carbon है, then heating by zinc, and this is called the carbon. Then FeO है या Fe2O3 है, then C है, CO के साथ करेंगे तो ये बन जाएगा Fe and plus that is CO2, this one. So balance it. So the process of smelting, the heating, the conversions of, this is also called smelting or the reduction. The reduction of metal oxide can be done by carbon and another metal act as a reducing agent. And here we generally know the carbon for the extraction of iron, and in the that is in extraction of that is copper, this one. So smelting. Now electrolytic, delta T already been defined. Now we get the metal, right? When we get the metal, then this metal is not 100% pure. This metal is called the impure metal, just impure metal. Impure metal. So what are the ways of this one? Purify. This is the, let me take the time. So impure metal, there are many ways to purify. Purify. Pala electrolytic refining. Electrolytic refining. Then another one is zone refining. Another one is vapor phase refining. Another one is chromatography. Like the distillation, etc. So the important one is electrolytic refining. For electrolytic refining, the principle, the metal to be refined, suppose we want to refine copper, Example, copper refining. Impure copper rod and act as anode. Pure copper rod will act as cathode. So it is anode, this is cathode, and it is connected with the battery. Now the salt, this is copper sulfate, is taken as electrolyte. The salt of the metal which is to be refined, its salt is taken as the electrolyte. Now keep in mind, impure will act as anode, pure will act as cathode. This is pure copper. Act as cathode. Okay? Now this is electrolyte is the salt solution which is to be refined. When we pass the electricity, what will happen? The rod which is impure, that lose the electron. So at anode, this copper impure will lose electron, get converted into copper ion. Now this copper ion at anode and at cathode, this copper ion will be deposited in the form of copper, so that the weight of this rod will increases and this will get deteriorated. And the impurities is deposited near the anode in the form of anode mud. This is in the form of anode mud. So electrolytic refining, that will, the principle, the metal to be refined will taken as anode, and the pure metal rod taken as cathode, and the electrolyte is taken as the salt of the metal to be refined. And when electric current is passed, the following reaction takes place. So copper impure, that converted into copper ion, and the which is deposited at cathode will act as pure copper rod. So the weight of that rod will increases, and the weight of this rod get deteriorated or decreases. Now where the impurities will deposited in the form of anode mud. This is called the electrolytic refining. Now there is some time, so I will take another. Now what is the zone refining? Zone refining principle है. This is zone refining, and it is said, write the name of the metal by which the is refined by zone refining process. You write the name of this zirconium. And by electrolytic refining, that is, we can refine zinc, copper, and this is this copper can be refined. So you will note the name of the metals to be refined by which process. You should know. Now, what is the principle? You know the principle. In the zone refining process, the impurities are soluble in the molten zone, while the pure metal is obtained on cooling. मतलब impurity जो है वो soluble होता है molten zone में, और pure metal जो होता है वो obtained होता है on cooling. This is the principle, and you don't write in the examination rod heated this one. So this is not the principle. You confine on the principle. So for that, this is a process. You understand it. This is a circular heater. Now this is impure rod. Impure rod. Very clear. Impure zirconium rod. Now this electric current is given. Now this rod is shifted. So when it is heated, the impurities get shifted. Suppose the heater is here. So impurities come here in the molten zone. Now this part becomes cooler. So this becomes pure. Now in this way, on shifting the circular heater, this is the process, just you note it. And when it come to that end, all the impurities are come here. Now this is, by cutting, this is removed and the whole rod will be purified. So this is the impurities, then this is the process by which this one is refined. The principle is impurities are soluble in the molten zone while the pure metal is obtained on cooling. This is the principle of the zone defining process, and the zirconium is refined by zone refining process. If time permits, then I will discuss this. So now the principle of the vapor phase refining. Vapor phase refining. Vapor phase refining, a principle. Principle. Vapor phase refining. So here, the impure metal is heated with suitable reagent at lower temperature, at low temperature, to convert in volatile compound which is heated at higher temperature to get the pure metal, and this reagent will come out. So this is the principle. This year the question is asked कि a metal is heated with suitable reagent, converted into the volatile compound, and which on further heating at higher temperature gives the pure metal. Write the name of the principle involved in that process. So you write is vapor phase refining process. And this vapor phase refining process contains two processes. One is Mons process, and another one is von Herkel process. And another question, name the metal which is refined by von Herkel process, that is nickel. Nickel plus 4CO. Here you write the temperature 330 to 350, right? And this is for nickel CO whole 4, and here it is 370, 350 to 370, or what suitable temperature, Ni plus CO, 4CO. Here you write impure, and here you write pure. This. So the process here is volatile compound. फिर से आप समझ लीजिए, इसमें क्या करते हैं, प्योर मेटल को एक सुटेबल रिएजेंट के साथ हीट करते हैं जो लोअर टेम्परेचर पर, ये केल्विन है 350 से 370 हो सकता। तो यदि टेम्परेचर याद नहीं रहे तो पहले एरो पर लोअर डालिए और हाइयर एयर बाद वाले एरो पर हाइयर टेम्परेचर डालिए, गलत बन डालिए। सो दिस इज निकल टेट्राकार्बोनाइट, ये वोलेटाइल। इसको जब हीट कर देंगे ये टूट करके निकल कार्बोनेट में बदल जाएगा, और इससे हम निकल को प्यूरिफाई कर सकते हैं, और इससे हम जिर्कोनियम और टिटेनियम को कर सकते हैं। जैसे Zr plus twice I2, that is Zr I2, low temperature. You will see the temperature in the book, and here is high temperature, that zirconium and plus I2, twice I2. So the metal. So this is all about the purification of the metals. So we are able to purify the metal by electrolytic refining, by zone refining, and by vapor phase refining. This vapor phase refining contains two Mons process and von Herkel process. And zirconium and titanium, remember it, कि पूछता है कि जिर्कोनियम को किस प्रोसेस से कर सकते हैं, तो जिर्कोनियम को आप जोन डिफाइनिंग से भी कर सकते हो और von Herkel से, never by Mons process. And name the metal which is refined by Mons process, you always write nickel. This is टेट्राकार्बोनाइट निकल। दोनों में वोलेटाइल कंपाउंड बना, ये भी बना, और हायर टेम्परेचर जब पर हीट किए तो जो मेटल अब प्राप्त होगा वह क्या होगा, 100% प्योर होगा। और प्योरिटी ऑफ मेटल इसलिए एसेंशियल है कि बिकॉज द मेटल हैव गॉट द कॉम्प्रिहेंसिव यूजेस। वी यूज द मेटल, जैसे टिटेनियम, जिरकोनियम, ये हाईली प्रीशियस मेटल्स हैं, तो इसका हम यूज किसी भी इलेक्ट्रॉनिक इंस्ट्रूमेंट में करते हैं तो इसीलिए इसकी प्योरिटी बहुत ज़रूरी होती है, इसीलिए हम मेटल को प्योरीफाई करते हैं. सो लेटर ऑन आई विल डिस्कस that is extraction of metal. It is already just equation is there, so I will if possible then I will discuss, and then we proceed on the next topics. Thanks.